Hey everybody, welcome back to the shop. So it's going to be a nice productive week here in the new shop, and I actually have Steve from Milltronics here this week, and he's going to be doing some hands-on one-on-one training with me on both of our new Milltronics, our 3016 TRM and of course our ML16 CNC lathe. Steve actually got here yesterday evening and stopped by, and we worked for a couple hours starting down there on the ML16 and started showing me some of the basic setup functions there. But he's going to be working with me. We're going to go through both machines. He's going to be teaching me how to program them. We're going to be using the conversational programming on the software here mounted onto the machines, and I'm really excited to start learning how to operate these properly. We started yesterday on the lathe, and we made a couple of test cuts on there, and we're going to probably pick it up from right there this morning, make some more test cuts, and probably get into some operations like grooving and threading, and you know, just learn some of the basic functions that you would always use on a lathe. And I know that there's going to be some more advanced training that we're going to do as we kind of get some of the basics behind us, but it's really exciting. And we'll be doing the same thing over here on the mill as well, learning how to, you know, use the Renishaw probe to find our workpiece and you know, work on tool offsets. We have the Renishaw tool setter in there, and we're going to be learning how to do that. So I'm sure there's going to be a lot of things. These 3 days are probably going to go pretty fast. I hope to get a little bit of video for my own personal use. Whenever Steve is showing me how to do some of this stuff, I might take some video for my personal use to be able to reference. But I also want to be able to show a little bit of this during this week of my experience with training with Milltronics, and share it with you guys here on the channel. So that's the purpose of this first intro here. I did want to mention that Derek from Milltronics was here last week. He spent a few days here. He came in and worked on both of the new machines and got them properly set up, got them level, calibrated, everything that needed to be done when you install a new machine, and got those guys ready to go for Steve this week to come down and do some training. Derek also installed our new Renishaw tool setter in the machine. It also works with the Renishaw probe there as well, that we'll be able to use to you know, find our workpiece locations and work offsets and things like that. So pretty exciting. We've got the Saunders Machine Works fixture plate mounted up in there, and oddly enough, I don't have enough of the plastic plugs to cover up all of the holes that's not being used, so I got to make another order for some of these plastic plugs right here so we can finish filling out the rest of those. I don't know what happened there. We do have a Saunders Machine Works mod vise. I've got my Kurt vise mounted in here as well. We've already got that tran. We did that yesterday. Okay, and then these are some of the tools that we've got set up just to kind of start with. So in the mill, we've got a 1/2-inch carbide end mill. That's our tool number 1, and Derek already did that, so I'm sure we'll confirm that. And then we've got a 1/4-inch carbide end mill, 3/4-inch carbide. I've got a face tool right here that we can use for some basic face milling. And of course, we have our Renishaw probe right here. And Derek also got this guy calibrated. So he set this guy up, and he set up the Renishaw tool setter right there. You have the receiver mounted on there. Sorry about it being dark. I haven't even turned the machines on yet, but once we fire them up, we'll have some lighting in there. And I've got a couple of clips I'll probably throw in there of Derek when he was here last week. He installed these top covers here. Milltronics sent these down and wanted to provide the top covers that also include a couple more lights on the inside there that'll help kind of brighten it up in here so that we can see a little better, and so you guys can see a little better for video use. So as I said, really excited about this. It's going to be a lot thrown at me at one time, but it is super exciting to finally get over here and start making some chips on the Milltronics, and I can't wait to learn some new stuff. So I'll bring you along for the ride. Hopefully we'll have some fun video to share of my little journey of trying to step in to the CNC world and learn some new things. All right, so we've inserted a piece of stress-proof 1.5" there, and just kind of edited our program. So we're going to face it, and we're going to turn it. It's going to chamfer it, cut a thread relief or a radius groove, and then cut a 12-pitch thread on there. Hopefully this one's going to turn out a little bit better. This is our second test piece. So what we'll do is hit preview, and this is going to show it going through all of the steps. You can see the chamfer there, radius groove, and then the threading. So hopefully this is what we're going to turn out with, and hopefully have some good finishes on there, especially with our threading. So let's give it a shot and see if we can make it happen. It's looking pretty good. So far, so good. That stress-proof finish is nice. You just got to watch out for those chips. That should be it, right? That's it. That looks pretty good. I like it. All right, so our second sample turned out pretty darn good. I ended up measuring the thread pitch diameter, and I was surprised that we were really close. So it's showing 0.02 big on the thread pitch diameter. So we've gone in there and made the adjustments on the, was it tool wear? We already went out of that screen, but we made a thousandths adjustment on the tool wear. So what I want to do, we're going to just flip this around. This is just a short piece I cut, and we'll rerun this and cut this again and see where it ends up at, and see if we can reduce this by 2 thousandths. But it turned out really good. This is just stress proof, so it usually machines really good, but it's been an excellent something to practice on, because it's all of your basic lathe operations. So facing, turning, a chamfer, grooving, and threading. So we're going to flip it around and try it one more time. Where do we go from here? Oh, run program, start, yep. Cycle start. There we go. Yep. That's the end of the program there. That's good. We'll get the mics out and measure it and see where our thread pitch ended up at. All right, we want 1.523. That's our target anyway. 1.523 and a half. Pretty close. That'll definitely pass right there. That'll go. Awesome. All right, so this was another little sample turned in that I did with a chamfer turn and a radius. We're actually going to run another program where we're actually using tool number 2 here with that radius insert to cut like a groove. That looks pretty nice. Looks awesome. All right, so we're using manual mode. We're also using the bore and bar. This is one of the Micro Quick solid carbide bars. And Steve's just showing me a feature using manual mode if you want to come in and just do another feature like this counter bore. So we're going to cut this counter bore again after we programmed it to do the initial bore there. This is just a one-time feature that we want to put into this part. All right, so I believe we're ready to go. We hit run, and then we're going to turn. So that looks good. We're going to turn the spindle on and hit cycle start. Making a pretty good chip there too. This is our finish. Yep. And it, all right, we're gonna hit stop. Yep. Okay. So that's a 3-inch diameter counter bore, 1/8 deep. Went red. Just testing out a little bit of longer turning here with some faster speeds. Making a 15th thou finish pass there, only about 1,500 RPM. There it is. Looks like it left a pretty nice finish there. All right, so this is another cool little machining op that I wanted to do, which was running at a more proper surface speed for the insert. We're using a DNMG insert, DNMG tool, and we're just turning it back 6 inches, but we're running a proper surface speed for that Walter insert. We've got it set, I think, at 800 surface speed. So let's fire it up and let it keep cutting. All right, that looks pretty good right there. Got a beautiful, beautiful finish on this silky stew. I do want to give it a measure just to kind of see. We've been playing around with some of the tool wear compensation as well. So, thousandths off right now. Not bad at all. So it's less than a thousandths off of being what our target diameter is, but that's beautiful. We had our spindle speed maxed out. We had the machine set at 2500, so it actually wanted to run faster than that, right? Because of the surface speed.
Right.
Yeah, so that's pretty cool right there. Awesome. RPM. We've almost maxed it out, huh? Gonna make a finish pass after this. I can honestly say that's the fastest I've ever turned on a lathe before.